Let's start by doing some multiplying. So it says multiply out or FOIL the following expressions. Remember that term FOIL we use when we're multiplying two binomials. And FOIL stands for first, outer, inner, last. So what we do when we're multiplying, we can apply that FOIL, or essentially all we do is you take everything from the first part, multiply it by every piece from the second. So we take our first terms, x times x. Remember, when you're multiplying the same variable, you add the exponent. So x to the first plus 1 is 2. X times x is x squared. X times 3 is 3x. So that's our outer. First outer. Inner would be 5 times x. And 5 times 3 is 15. So then from there, we just combine our like terms. So 3x plus 5x is 8x. So we have x squared plus 8x plus 15. Okay. Here, take everything from the first, multiply by everything from the second. So x times x is x squared. X times 1 is 1x, or just x. 7 times x is 7x. And 7 times 1 is 7. Combine like terms, x plus 7x is 8x. So we get x squared plus 8x plus 7. For the last one, we take x times x is x squared again. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. Combine like terms. So we get x squared plus 8x plus 16. Okay. So there's multiplying. What we're going to be doing today is factoring, which is essentially doing the opposite. So starting from what we got as our solution, moving back towards where we started here. So as we go through these, it's helpful to remember kind of these types of things. What two numbers multiply to 10 and add to 7? That's something we're going to be thinking about. So think about what two numbers will both multiply to 10 and add to 7. So the numbers that multiply to 10 would be 10 times 1. That doesn't also add to 7. 5 times 2, that multiplies to 10. That does add to 7, so 5 and 2. Same idea here. The two numbers that multiply to 20 and add to 9. So 1 times 2 will give me 20, but those don't add to 9. 2 times 10, that's 20, but 2 plus 10 is not 9, it's 12. 4 times 5 is 20. 4 plus 5 is 9, so 4 and 5 would be our solutions. Same idea. Numbers that multiply to 24 and add to 11, in this case would be 8 and 3. Okay. Probably kind of a weird thing you're thinking for me to ask you to do this, but it will definitely come in handy. So as we think about quadratics, we want to think about them in terms of kind of their generic form. So a quadratic is generally written as ax squared plus bx plus c, where these a, b, and c are just numbers. So like if we have 5x squared plus 6x plus 8, and we want to identify what's a, what's b, and what's c, we just look for the numbers in front of x squared, in front of x, and then alone. So our a is always our number in front of x squared, so in this case a would be 5. Our b is always our number in front of 6, or in front of x, so in this case it'd be 6, and our c is just our number in the end, which is 8. So what I'd like you to do here is just identify a, b, and c for each of these problems. So 6x squared plus 3x plus 12. A always goes with x squared, so our a would be 6. B always goes with x, so our b would be 3. C is always just our number, so that would be 12. Number 2, 4 is with x squared, so that's a. 3 is with x, so that's b. Negative 10 is our number on the end, so our c would be negative 10. Here we have just x squared, so the number here would be a 1. Not a 0, because 0x squared is 0. 1x squared is just x squared. 5 is our b. 54 is our c. Okay. So what we're doing here with factoring now, this is kind of covering the most important piece of this unit today. And what we're going to do in the way that we factor, so if we want to factor the following quadratic expressions, we want to think what multiplies to c and adds to b. So as we look here, let's start just by identifying a, b, and c. So our A here is 1, our B here is 10, our C here is 24. And whenever you have an A value of 1, you can factor it by thinking what are the two numbers that will multiply to C and add to B. Multiply to C and add to B. And we'll talk about what that looks like as a final form. But think about what numbers multiply to 24 and add to 10. So if we think about what multiplies to 24, 1 times 24 is 24, but 1 and 24 don't add to 10. 2 times 12 is 24, but 2 plus 12 is 14, not 10. 3 times 8 is 24, but 3 plus 8 is 11. 4 times 6 is 24, and 4 plus 6 is 10. So 4 and 6 are the numbers that multiply to C and add to B. So what we can do, or how we can factor out x squared plus 10x plus 24, is we can write that as x plus 4 times x plus 6. So what we're doing here is we're doing the reverse of the do now. This is called factoring, when you write it as an expression of multiplication of two factors. And the way that we do that, again, we look for what multiplies to C and add to B, and those are the values that go here, x plus 4, x plus 6. And if I were to go ahead and multiply this back out, so do x times x is x squared, x times 6 is 6x, 4 times x is 4x, 4 times 6 is 24, so I'm just foiling. Then combine like terms, we do end up with x squared plus 10x plus 24. So you can always multiply out to just kind of check, make sure you've got that correct. Okay, so for number 2 here, zoom in a little bit for you. For number 2 here, let's start by identifying A, B, and C. So our A is 1, our B is 14, our C is 40. So we're looking for two numbers that'll multiply to 40 and add to 14. It's usually easier to think about what multiplies first. So try this. Think about what numbers multiply to 40 that would add to 14. So we know 1 times 40 is 40, but that's not 14. 2 times 20 is 40, but that's not 14. 4 times 10 is 40. And 4 plus 10 is 14. So if I want to factor this out, it would become x plus 4 times x plus 10, because those are the numbers that, 4 and 10 are the numbers that multiply to 40 and add to 14. Again, I should say, this only works when your A value is 1, which is what we'll be just doing today. Okay. Third one. So again, let's identify A, B, and C. So A is 1, so we can do our process here. B is 32, C is 60. So we think what multiplies to 60 and adds to 32? What multiplies to 60 and adds to 32? So think about what numbers multiply to 60. Well, 1 times 60 is 60, doesn't add to 32. 2 times what is 60? 2 times 30 is 60. And 2 plus 30, that's 32. So we would write it as x plus 2, x plus 30. And I should note for this, it doesn't matter which order you put your factors in, so you could write this as x plus 30 times x plus 2, and that's okay as well. Either way is fine. It doesn't matter what order you put your factors in. It's still the same solution. Okay. All right. So you have 6 problems here, so go ahead, pause the video, give those 6 a try on your own, and then we'll talk through them together. Okay, we're back. So we're looking for numbers that multiply to C and add to B. So for number 1, numbers that multiply to 15 and add to 8, that's 5 and 3, so we'd write it as x plus 5 times x plus 3. Numbers that multiply to 24 and add to 11 would be 8 and 3, so we write that as x plus 8 times x plus 3. Multiply to 30 and add to 13 would be 10 and 3, so x plus 10, x plus 3. Multiply to 35 and add to 36, that'd be 35 and 1. Multiply to 48, add to 16, that would be 4 and 12. and multiply to 56 and add to 15 would be 8 and 7. So those should be your 6 solutions there. All right. Or wait a minute. Yeah. Okay. So everything that we've done so far has only positive values. Let's look at what happens when we have some negatives. So as we look at this trinomial here, x squared plus 11x minus 12, we have a negative number. We have a negative 12. However, when we go about factoring here, the process stays the same. We still think what multiplies to c and adds to b. Just our c is a negative number, so we'd be looking for numbers that multiply to something negative. So as we look here at x squared plus 2x minus 35, our a value is 1, our b value is 2, our c value is negative 35. So we are looking for numbers that multiply to negative 35 and add to 2. So as we think about numbers that multiply to a negative, we know to get a negative, you have to multiply a positive and a negative number. 2 positives multiply to a positive. 2 negatives multiply to a positive. So it has to be 1 positive, 1 negative. So not only would 1 times negative 35 equal negative 35, but negative 1 times 35 equals negative 35. So you have to think about it in both ways as you're determining what multiplies to c and adds to b. In both of these cases, it doesn't work because 1 plus negative 35 is negative 34. Negative 1 plus 35 is positive 34, so it doesn't work out. So let's think about our other factors, other things we can multiply to get to c. So 2 times something doesn't work, 3 times something doesn't, 4 times, 5 times 7, or 5 times negative 7 would give me negative 35. 5 plus negative 7 is negative 2, so we're close. So let's just flip them. So what if we do negative 7 plus 5? Well, that's 2. Negative 7 times 5 is negative 35. So our factors would be x minus 7 and x plus 5. These would be the numbers. Now as we look, negative 7 times 5 is negative 35. Negative 7 plus 5, or whoops, what am I doing? Sorry, not negative, sorry, we want positive 7 and negative 5. What am I doing here? Positive 7 and negative 5 will give us positive 2. And also multiply to negative 35. So we'll have x plus 7, x minus 5. Sorry about that. 7 times negative 5 is negative 35. 7 minus 5 is 2. Let's look at another. So our a value here goes with x squared, a is 1. B goes with x, negative 10. C is 16. So in this case, our b value is negative. So we want two numbers that multiply to 16 and add to negative 10. So we want them to multiply to a positive. So what types of numbers multiply to positive? Well, a positive times a positive is positive, and a negative times a negative is positive. However, a positive plus a positive would give us a positive b. A negative plus negative would give us a negative b. So we need two negative numbers to multiply to 16 and add to negative 10. So we can think through our possibilities. So negative 1 times negative 16, that's going to multiply to 16, but not going to add to negative 10. Negative 2 times negative 8, that's going to multiply to 16, because negative times negative is positive. And it also is going to add to negative 10, so our factors would be x minus 2, x minus 8. Okay, so very similar to working with positives. You just have to think a little bit more about those negative values sometimes here. Okay. All right, let's do a few more. All right, so x squared plus 2x minus 24. Our a value is 1, b value is 2, c value is negative 24. We think what multiplies to negative 24? And we'll add to 2. Well, it's got to be 1 negative, 1 positive, so multiply to negative 24. So you can start thinking through negative 1 and 24. It's not going to, that combination isn't going to add to 2. 2 and 12 will multiply to negative 24. It's not going to add to 2. What about 4? Negative 4 and 6 multiplies to negative 24. Negative 4 plus 6, well, that's 2. So our values would be negative 4 and 6. So as you work through these, there might be some mental guess and checking you have to do, thinking through. That's okay. As you do a lot more of these, it'll start to come a lot easier. Number 2, 1, negative 5, and negative 36. So we think what multiplies to negative 36 and adds to negative 5? And we can do this because our a is 1. It's got to multiply to a negative, add to a negative, so there's got to be a positive and a negative, with the negative value being further from 0 or larger, kind of in a way. So we think 1 and 36, or 1 and negative 36, nope. 2 and negative 18, that wouldn't work. 3 and negative 12, that wouldn't work. 4 and negative 9, that sounds promising. 4 times negative 9 is negative 36. 4 minus 9, or plus negative 9, is negative 5. That checks out. So we'd have positive 4 and negative 9. Same idea here for the last one. Our a value is 1, b value is 1, c value is negative 30. So it's got to multiply to c, add to b. Multiply to negative 30 and add to 1. So we think through. Negative 1 and 30, not going to work. Negative 2 times 15. Negative 3 times 10, still not going to add to 1. Negative 5 times 6, ooh, that multiplies to negative 30 and adds to 1. So it'd be x minus 5, x plus 6. Okay. All right, that basically covers what we're doing, so let's get some more practice here. So you have 4 problems here, all with these negatives, so why don't you pause the video and try those 6 problems, on your own. Okay, we're back. So here you should have x minus 5, x plus 3, then x plus 6, x minus 3. Next, x minus 9, x minus 1, kind of a tricky one. Here we will have x minus 8, x plus 5. Next we have x plus 9, x minus 2. And the last one here, we have x minus 2, x minus 16. So you're always just looking for numbers that multiply to c and add to b. Okay. All right, final 6 problems, putting everything together, front side, back side of the notes. Again, pause the video, give these a try on your own. This will be a good check to make sure you've got it down. Okay, here we go, we're back. X plus 8, x plus 2, x plus 6, x minus 2, x plus 8, x plus 3, x minus 7, x minus 2. Number 5, we have x plus 18, x plus 2. And number 6, we have x minus 5, x plus 4. And there you have it. Those are our solutions. Those are our factors. Tomorrow, you'll be spending some time focusing on your next piece of this learning target, which has to do with finding roots.